Hello everyone, how's it going? My name is Dan the Tutor. In today's video, we're going to be looking at some practice problems that use motion and graphs. The first thing I want to tell you, whenever we have a graph problem in physics, it means that we're probably either going to be finding the slope or the area under the curve. And you need to know which one we are looking at. And so let me start out by giving you a little roadmap for what we're going to be doing today. There are three quantities in motion: position, which is symbol x or y. You have velocity, which of course is v, and you have acceleration, which is symbol a. And we can go back and forth between position, velocity, and acceleration with graphs using the following relationship. If you want to go from position to velocity, then you are looking at the slope of the graph. Similarly, if you want to go from velocity to acceleration, again, it's the slope. So when you want to go forward, in other words, position to velocity or velocity to acceleration, we are looking at the slope of the graph. And if you want to go in reverse, such as acceleration to find velocity, that is where you're going to be using the area of the graph. And the same is going to be true for velocity to position. That's going to be area as well. We're going to be doing example problems with this today, but in general, if I give you the velocity graph and I ask a question about acceleration, find the slope. Equally true if I give you a velocity graph and I ask for the position, find the area. And so that's basically all the notes I have to say before we start doing some problems. So let's go ahead and get into it. First question I have here, I have a big graph. This is going to be a velocity versus time graph. 1, 2, 3, 4, 5, 6, 7 on the time axis. And on the y-axis, we're going to have counting by twos, 2, 4, 6, and then -2, -4, -6. So here's the graph. We're going to start at -4, pass through 1, ultimately get to 6 right here at 2.5. So we're at 6 now. Then we're going to continue forward here until 4.5, and then we're going to come back down until we get to -4 again at 7. And this point down here is -4. Oh, and this point is 4.5. And my question for you is I want you to find the acceleration of this graph at the points time equals 1, 3, and 5. So the first thing I want to tell you is if I give you a velocity graph and I want acceleration, I hope you know I gotta find the slope at each of these 3 points, 1, 3, and 5. So first, if I want to find the slope at 1, first thing I want to tell you is you're not going to find the slope at 1. You're finding the slope between 0 and 2.5. In other words, it's the slope of the whole black line. So hopefully you remember the slope equation. You can either say rise over run, or you can say y2 minus y1 over x2 minus x1. I don't care which one you say. If I go with this equation, y2 is the top point 6 minus y1, which is the first point, -4. That will be a double negative. It will become 10. Divided by x2, which is 2.5, minus x1, which is 0. So it's going to be 6 minus -4, 10, divided by 2.5. Plug that in a calculator. You'll get 4. In other words, the acceleration at time 1 is 4 units meters per second squared. So that's it for 1. Now we got to find 3. So the slope right here, hopefully you realize this, it's going to be the slope of this entire line segment, which this slope is really easy. The slope is 0. It's a horizontal line. If you do rise over run or y2 minus y1, you will see that the slope is 0. So at t equals 3, it's going to be 0 meters per second squared for the acceleration. And then finally, for 5, what's the slope of this line segment right here? Well, we got to do either rise over run or y2 minus y1 over x2 minus x1. This time, I'm going to show you how to do rise over run because it is the faster method. The rise, starting from right here and ending from right here, we are going down from 6 to -4. You are going down 10 units. 6 plus -4, down 10, meaning the rise is -10. The run is going to be how far we're going to the right. You're starting at 4.5 and ending at 7. So 7 minus 4.5, it's going to be 2.5. and you do negative 10 divided by 2.5, that's going to give you negative 4. Slope of that line is negative 4, meaning at time t equals 5, the acceleration is going to be negative 4, and that's meters per second squared. So that's it for the first one. We got a couple more examples for you to give it another try at, gain some mastery. And so here's the next one. For the next one, I'm going to have a position versus time graph, x versus t. So for this graph, we're going to start at 0, go up to 1 right here at t equals 2. Then we're going to go flat for a couple seconds. Then at 4, we're going to shoot up to 5, 3 right there. And then for the rest of the time, we're going to be flat again. And for this one, the question's going to be, I want you to find the velocity at t equals 1, 4.5, and 7. So go ahead, give this one a try. If you don't know how to do it, then just keep watching, I'll explain. And so here's what we're going to do. First of all, I gave us a position versus time graph. I'm asking for velocity. That means we need the slope. So first, to find the slope at 1, if you do rise over run, the rise is up 1 because you're starting here and you're ending here. So we're going up 1 and then over 2, meaning the rise over run is positive 1 over 2, so it's 1/2. And that's it. The velocity at t equals 1 is 1/2 meters per second. Again, that's for t equals 1. Next, 4.5, this point right here, we gotta, again, just find the slope of that line. I like rise over run. The rise is up 2 over 1. So then at t equals 4.5, rise over run was 2 over 1, giving me a velocity of 2 meters per second. And then for 7, looking right there, slope of the line's flat. Whenever the line is flat, the slope's going to be 0. So at t equals 7, the slope or the velocity is going to be 0 meters per second. And there we go. We just did another one. Now I've got one more for you. This one is going to be different from the rest. I have a velocity versus time graph. So for the first few seconds, it's going to be going straight. Then at 3, we're going to jump up to right there. And then we're going to go back down for the rest of it. And my question for you is not the acceleration. I want you to find the displacement from 0 to 6 seconds. So maybe you've got an inkling of what to do. I will tell you as a hint, displacement is the same thing as change in position, which means that if we want velocity and we're going to position, it means we are using the area this time. And I need the area from 0 to 6. If you want to try it on your own, go ahead. But if you don't know what to do, here's the solution. Split it up into different shapes. There's a few different shapes we can split it up into here. For instance, I can have a blue rectangle right here. I can have a green rectangle right here. A little purple triangle right there. And then last, a big black triangle right there. So then I just got to find the area of these 4 shapes. For the first one, the blue rectangle, area equals base times height. The base is 3, height is 2, so that's 6. Very easy. For the green, very similar thing we're going to do. It's just a rectangle, base times height. The base is not 4, the base is 4 minus 3, so just 1 times a height of 2. So that area is 2 for the green. Then for the purple, it's a triangle, so 1/2 base times height. Base is, again, 4 minus 3, so 1. And the height is 3 minus 2, so 1. Looks like the area is 1/2 for the purple. And then finally for the black, it's going to be, again, 1/2 base times height, because it's a triangle. The base is 2, because 6 minus 4 is 2. And then the height goes up to 3, so that's going to be 3. And then finally, if I just want to find my displacement, I got to add these 4 areas together. So 6 plus 2 plus 1/2 plus 3. And if I plug this in a calculator, then I'll get a final answer of 11.5. And the units are meters for displacement. And what this basically means is that wherever I started at t equals 0, I am 11.5 meters forward than I was before. So if I started at the 0 mark, I'm now at 11.5. If I started at the 10 meter mark, then 10 plus 11.5 is 21.5. In other words, displacement is not the same thing as position because displacement is change in position. It's the change. And so hopefully that makes sense to you now. That's all the questions I wanted to look at for today. Thank you all for watching. I hope you have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.